Idaho National Laboratory is the not-so-hidden gem of southeastern Idaho, filled with engineers and scientists pursuing efficient energy practices in the United States. They have hundreds of employees studying many different ways to do just that. During our visit to the facility, we learned how integrated energy systems help create cleaner hydrogen that can be used in everything from fuel to agriculture. Further research into the production of clean hydrogen is one way that INL is combating climate change and reducing overall carbon emissions. To learn how the process begins, we spoke with TJ Morton, an experimental systems engineering lead for the Integrated Energy Systems program and the microreactor program at INL. We followed him as he showed us how integrated energy aids in clean hydrogen production.
So here in our integrated energy systems, experimental systems, we are working on integrating the thermal systems we have, the microreactor test bed behind me and the thermal energy distribution system with the solid oxide electrolysis demonstration platforms outside. So I say integrated, and I mean that we would be able to provide heat from a microreactor test article through our thermal energy distribution system. We would provide that heat to a boiler to make steam for electrolysis.
Essentially, the process of creating hydrogen starts inside, using the TEDS, the Thermal Energy Distribution System. This system is a network of pipes, pumps, and heat exchangers. It begins at the pump, which brings eco-friendly oil to a 200 kilowatt electric resistance heater. The oil is heated to about 315 degrees and then pumped through the thermal energy storage device, a tank full of ceramic beads. Ceramic has a very high heat capacity and holds heat very well. The oil then travels to a heat exchanger where it is transferred to a thermal energy user, like the electrolysis machines used in hydrogen production. This entire cycle normally takes a minute or two to complete, but is continuously cycling through. While the TED system currently uses electric heaters, the goal is to eventually replace those heaters with nuclear fuel. As they learn how to produce and harness this thermal energy, the Integrated Energy Systems program is trying to find other ways to utilize heat through other natural resources, using wind turbines, solar panels, and more. The end goal is to store the heat produced in these systems and then transfer it to the process that produces clean hydrogen. Morton believes this will be a much more cost-effective solution to energy production as they continue their research.
The only way a commercial, a baseload plant like a nuclear power plant or a coal-fired power plant stay effective is when they can operate at 100% power all the time. So if we could use that thermal energy during the day when wind or solar is picking up the grid, if we could use that heat from a commercial nuclear power plant to make hydrogen, then the commercial nuclear power plant stays 100% power all day so they can stay cost effective.
So, in the process of integrated energy, there are three pillars: heat, electricity, and energy storage. Currently, we see heat production from burning fossil fuels, but the hope is to eventually turn that responsibility over to nuclear energy generation. That produced heat can be used in electricity, converted into hydrogen, or stored. As we visited, we learned more about its role in the process of producing hydrogen. We toured with Dr. Ameya Sugarkar, a research engineer in Hydrogen and Thermal Systems Group. He showed us the second part of hydrogen production. This is the system that the heat previously created by the thermal energy distribution system is transferred to. As it's transferred, thermal energy enters the machine that has a balance of plant, which consists of a steam generation unit, an air supply unit, an electricity production unit, and other instruments that monitor the temperature, flow rate, amount of electricity being provided, and how much energy is being produced. This system performs electrolysis. Electrolysis, in base terms, is the process of splitting something apart using electricity. As the heat from the TED system enters the machine, it creates steam. The steam goes through stacks of solid oxide electrolysis cells. A solid oxide electrolysis cell is a small sheet, one side being an electrode and the other an electrolyte. As the steam flows over one side of the cell and electricity is added, the cell splits the hydrogen and oxygen present in the water vapor. This leaves them with hydrogen on one side and oxygen on the other. The oxygen gets swept off, and any excess hydrogen is vented out into the atmosphere. But soon, as they develop bigger machines, They will collect that clean hydrogen instead. They are expecting to have a much bigger electrolysis system up and running by January 2024 that will change the current production of 65 units of hydrogen per day to 165 units per day. At that point, they will have a post-processing system that will capture hydrogen, then dry, compress, and store it. SugarCar hopes that as the production of clean hydrogen increases and is a main source of hydrogen, its price will decrease, making it much more accessible to commercial companies.
High cost is the only risk that comes to my mind. But as I said, with more deployment, it's going to go away. And our hydrogen systems are pretty efficient, and they're competing with the conventional systems already. The IRA, the Inflation Reduction Act, that is giving tax credits for clean hydrogen production. That's $3 per kilogram of clean hydrogen that is being produced that you can write off in your taxes. Those incentives from the government also help, deploy larger scale systems. Coupling hydrogen with renewable energy and clean energy sources such as nuclear power plant or solar and wind also help produce, cleaner hydrogen. So those are the things that we're aiming for. And with time and more deployment, hydrogen is just going to get bigger and bigger.
During our visit, we began to truly understand the goal behind INL, especially as we learned more about the engineers' work with integrated energy and hydrogen production. With this research, our energy future can only improve, and it can serve to genuinely make the world a better and cleaner place. From BYU Idaho Scroll, I'm Erica Cook.